In example 3, we want to do pretty much the exact same thing we did in example 2, except now we have an equation that's written in standard form, which is something of the form ax plus by is equal to c. We have all the same information, it's just written in a different order, a different format. So what I like to do with problems like this is go ahead and rewrite this equation so it's in that slope-intercept form. Meaning what we have to do is isolate the y variable on one side of the equation by itself, and then we can just use the y-intercept and the slope to relatively easily graph our line. So in this case, we have 4x plus y is equal to -2. Keeping in mind our goal is to isolate that y variable, what we want to do first is subtract 4x from both sides, which will leave us with y is equal to -4x minus 2, and we're done. If we did have a coefficient in front of the y variable, we'd have to divide both sides by that, but in this case, y was isolated by itself already with just a coefficient of 1. So we can identify our slope, which will be, we can identify our y-intercept, which is -2. So we can start off by plotting the point 0, -2. And then our slope in this case is -4, which we can write as -4 over 1, which tells us to plot our next point, we move down 1, 2, 3, 4 units, and to the right 1. Because we only treated one of those values as a negative, the other as a positive. And then we can graph the line that represents the infinite number of solutions to that original equation.